Okay, so this lesson we are going to talk about a theorem. It's called the maximum flow, max flow, and the min cut theorem. Our motivation is because what we described before is intuitive to know the value of f is always less than or equal to the capacity of any cut. So if we have a capacity of a cut, then it is an upper bound for the flow. And on the other side, if you have a flow, then you know it is a lower bound for the capacity of the cut. So suppose the equality hold, then this f and this cut, both of them are optimal. 当等号成立的时候呢，这个流量和这个截集呢，流量就已经必定要是最大的，然后呢，这个截集呢也注定要是最小的。但是难就难在你怎么找到这个 f， 你怎么找到这个 cut。So later on, our goal is try to increase the f and also decrease the capacity, and in the end, we are going to find such an f and such an a and b, and so that they are both optimal. And this is an efficient and effective algorithm, and it can help you to solve many problems. There is only one idea in this algorithm. It's called augmenting path. Okay, and here is its definition. Suppose we have a network and we have a flow already. Given a network, given a flow, and we will build a new graph, gamma f, as follows. Okay, and first you have the set of gamma f is the same as the vertices of gamma. For every edge, okay, if I have an edge in gamma, then we do the following. Okay, let me draw it here. U, V, and we have the flow of UV. And it is supposed to be less than or equal to capacity of UV and supposed to be greater than 0. So there are two cases. Well, they are not mutually exclusive. 就是有两个不见得互斥的状况。Okay. The first case is when this is not equal to C. If f is less than c, then we know we can increase some of the flow, right? We can increase the flow a little bit. On the other side, if f is greater than 0, then we know we can decrease the flow. Very natural observation. So we'll do the following. If f is less than c, by less, I mean strictly less than c. Then we add an edge. we add this direction to gamma f, and with the weight. As the difference. And you can guess the other side. Suppose f is strictly positive, strictly greater than 0. Then we are going to add the opposite direction. So this means if case 1 happens, we are able to increase the flow by C minus F. If the second case happens, then we are able to decrease. By decrease, I mean getting some flow from the opposite direction and decrease the flow by F. 所以这两个 case 它们并不互斥，它也许两个会同时发生。你可以上升的时候呢，你就把正向那边呢加一条边；可以下降的时候呢，就把逆向加一条边。那加上的这条边呢，会有一个数字在旁边。那这个数字呢，是表示说你可以增加或减少多少。少一个 m 吗 ？s 可以再讲一次吗？
少一个 m， 那个点 f。
哦 ，OK， 谢谢。Okay. So let me give you an example. This is the example we have all the time. Okay, and let's consider the case that we only have one a flow at the bottom, and others are 0. We know this one is not optimal. It is not good. We have some better way to increase the flow, but let's try to make it look at this definition first. Okay, so gamma is this graph, and the blue numbers are flow. With this gamma and this f, we are able to generate the graph gamma f. Okay, so first of all, we say the gamma f have the same set of vertices as gamma. So this is the vertex set of gamma and gamma f. Now for each edge, we either add UV or add VU or add both. Now let's look at this one. From S to this vertex, this edge, the capacity is full, but it is positive. So this means that I cannot increase any capacity. I cannot increase the flow anymore, but I'm able to decrease it by 1. So I can decrease the value by 1, but I'm not going to add any edge from left to right. Okay, and let's do this process for each of the edge. So the middle one, it is full of capacity, and we are not going to increase it. But the last one, the capacity is 3, the flow is 1, so we can still increase the flow by 2. But meanwhile, it's also possible to decrease the flow by 1. 所以看这个1、3的这个 case 呢，1可以再增加2嘛，正向你可以加2，逆向可以减1，所以它可以就两条边都给它加上去没关系。这就是刚刚讲说这两个 case 并不是互斥的，你同时发生都没关系。好，那剩下的我就把它画完，然后我就不解释太多。I will just draw the remaining, and I believe you can finish them. So I think this should be quite straightforward, and now you can have an understanding of what does these numbers mean. These numbers tells you that you can go on this direction, increase or decrease the flow, and try to do something else, right? It helps you to understand better about your freedom. You can increase or decrease. So for example, in this gamma graph, you realize there is a path going from S to T. And what does this mean? This means that I can increase by 3, I can increase by 1, I can increase by 3. And it means that I can increase the flow by 1. 3, 1, 3, the smallest is 1, and we can increase that by 1. So I can follow this direction to increase by 1, by 1, and by 1. OK， 所以就这一条，你如果在伽马 F 上呢找到一条路径是从左边到右边的，那这条路径呢，它就会通过很多数字。这些数字呢，就是像刚刚我一开始讲的例子一样，会有一个瓶颈，那个瓶颈呢就是最小的数字。那313那就是瓶颈就是1。那虽然说你不可能不能增加3，但是你知道说这一条路线呢，你可以帮大家都增加1，所以呢，你就可以在上面这里呢做一些更改的动作，你就可以帮这个增加1，这个呢增加1，这个也增加1，那这样就是刚刚我们第二个找到的线。那如果你再做同样的事情一次的话，你就可以再更新伽马 F。那更新伽马 F 以后呢，就可以再做类似的事情。OK。So let's define such a path. You see, this path tells you that there is a way that you can increase the flow. So it's called an augmenting path. Augment 就是扩增啦，跟线性代数的 augmented matrix 增广矩阵是一样的。Augmenting path is a path on gamma F from S to T. The value of an augmenting path is the minimum number on its edges. 不好意思，如果字写太小，再跟我讲一下。 So in this case, 1 is the minimum value, and so the value is 1 is the minimum weight on this path. So the value is equal to 1. And later on, we are just going to increase the value by increase the flow by 1. Okay, so this is an augmenting path. And the value is equal to 1. Okay, so later on, this is pretty much the most essential idea of the algorithm. If you build this gamma f, which is very natural, and then you try to find an augmenting path. To find this augmenting path, you can use BFS, DFS, and whatever the algorithm you want to go from S to T. If S can go to T, then you found an augmenting path, and you are able to increase the flow by a little bit. And then you update the flow. Once the flow is updated, gamma f is updated again. Use the new gamma f, then you find the augmenting path again, and keep working on this until there's no augmenting path. 所以接下来要做的事，这就是有 augmenting path， 你就帮它更新一下。更新 f 以后呢，这个 gamma f 也会跟着动。动完以后呢，你就可以再去找看看有没有 augmenting path。那一直找到它没有，那我们就停下来。So this algorithm is called Ford and Fulkerson. Okay, and the goal is try to find the maximum flow in a network or find the minimum cut in a network, and it will generate both the flow and the cut simultaneously and make sure that this is optimal. Okay, so the first step, set the flow as 0. By 0, I mean it is a function, right? It is 0 on every edge. Secondly, you can build gamma f. And if there is an augmenting path, then you can update the flow. And I will leave it to you about what is the meaning of update. Okay, I will show you several examples, but I guess it is meaningless to write down the detailed description of that. 这个 update 呢，等一下就会看，它是一个很自然的一个动作。好，那所以我就不写它到底是怎样 update。哦 ，F 等于0的意思就是说，因为 F 总之就是我们先设定初始值，每一条边上面都是0。
哦，所以不用像刚刚那样先。
对，一开始就是把大家都先写一个0。 然后下一步可能就会帮你找到某一些地方是一，然后在下一步会再找到更多一。Okay, and that's done. Just repeat step 2. Until no more augmenting paths are found. So after you update this, you will keep track of the f. The f will increase one by one, little by little, and you will. So you always have the f. Now, what is the cut? Then we define the following: that A be all the vertices U such that S can reach U in gamma F. And B is the rest of vertices. Cannot. So recall that this algorithm will stop when there is no augmenting paths. This means it is impossible to go from S to T anymore. 这个演算法会停下来，只有在这个 augmenting paths 找不到的时候。那找不到的意思就是说 S 是走不到 T 的 ，OK？ 而这个意思就是说，你这里 A 和 B 呢，就把它分两类，一类是 S 走得到的，一类是 S 走不到的。哦，那 T 应该要在另外一边 ，T 应该要在 B 那边。Okay, so A and B is a partition of the vertices, and you know that A collects all the vertices that you can reach from S. But B is all the vertices that is outside of the that you cannot reach by S. So T belongs to B. T is on B. Because there is no augmenting path. And thus A and B is the cut, and you can return. Return F and the cut A and B. So I will give you a few seconds to digest, and I will give you an example. Now, let's look at our example. Demonstrating this algorithm requires me to draw this graph several times. And anyway, I will put this slide on Cyber University, so it's really up to you. You don't need to write it down, okay? So, what is it? 1, 1, 1, 1, 3, 3, 3, 3. Okay. So at the very beginning, we set every flow as 0. Now you can build the graph, and this graph is actually the same as the original graph because everything is 0. and the weight on it is the capacity. Now you can run the BFS or DFS to find a path. So for example, we found a path to go from S to T, and the value is equal to 1. So we are going to update the flow along this augmenting path. And by update, I mean just follow this direction and keep increasing that. Okay, so it becomes 1, 1, 1. Now f is updated, and the value of f is increased by 1. Okay. So this is good. The value is increasing. Now let's try to draw the gamma f again. That's why you need the computer, right? Now you see the f is updated, so I cannot go to this direction anymore. It becomes an opposite edge. Okay. We drew this graph before, so I just do it without too much explanation. And you can run the algorithm to find a path from S to T. And this time, we found the one on the top. And the value of this augmenting path is equal to 1 again, because it is 313. So that's updated. We have 1, 1, 1, 1, 1, 1. Okay, almost there. Let me draw it again. And you will realize that the value of f increased by 1 again. It becomes 2. And now let's try to draw the last part. You can go here by 2, come back by 1. Okay. Anyway, it's getting more and more complicated, right? Okay, I believe you know what to do. I'm trying to find a more interesting path here. Okay, so previously we choose this path, right? And it will finish the algorithm immediately. But let me choose something else. Because you are running an algorithm, you don't really know which path is better. You can choose something like this. You can go around and it's longer, but still it works. And but again, this has value equal to 1. Okay, and for your convenience, I will copy this part to the next page and try to update the value for you. Okay, so we're going to update this one. All right, so we have a path. We have a path that is going to this direction, right? So we're following this path and try to increase the number. Increase by 1, so it becomes 2. And then it dropped down to here, so increase by 1. But now this is an interesting place because it was a flow from left to right, but your augmenting path is going from right to left. And right to left means that this flow can be decreased. So it will decrease to be 0. And you can keep going on this direction. It becomes 1. And finally, increase this by 1. So I choose this path to demonstrate that in some cases, your augmenting path is on the opposite direction. And opposite direction means that you have to decrease the flow instead of increasing the flow. But it still works. If you check the conservation law, you have 2 in and 2 out here, and 1 in, 1 out here, 1 in, 1 out here. It's like you have a path, and another path here. You still can find 3 paths from left to right, but just somehow showing you it is possible to decrease the flow, but still increasing the value of the total flow. And up to now, the value of f is equal to 3. And if we try to draw the graph again, gamma f becomes, we'll use your imagination. This is 3, and you can go back by 2. 1, 2, 1, 3. 2 and 1. 1, 1, almost there. 1. Okay, I believe you can do that. So after we build the gamma f, and recall this one is S, and recall this one is T, let's try to find an augmenting path. Now, S can only go up, right? You cannot come, this one is the wrong direction. You can only go outside. And then you cannot do anything. You can go only up to here, and then it's all the direction backward. So this part is all the vertices that you can reach from S, and it is called A. The remaining vertices that cannot be reached, including T, those are called B. And now you realize that, okay, this is a cut. It is A and B. And if you recall what we have the cut at the very beginning, this is exactly what we found. Okay, so I did not give a proof of why this worked, but I just keep updating the augmenting path, and in the end, you just return this blue F, and also the green cut A and B. And actually, the result is this is our both optimal.